And welcome to the review from Module 11. This is Mr. Holloway, and this is our review packet. So the first question is, Mark has several coins in his pocket. He has 9 quarters, 4 dimes, 10 nickels, and 4 pennies. And it wants us to write an expression of how much money Mark has in his pocket. Now remember, it's important to understand that an expression does not mean solve it. An expression is a way of saying a number. So we can do this a couple different ways. We can go on ahead and say that quarters is a Q, and we can say that dimes are a D, and nickels are a N, or pennies are a P. And if we do that as our variables, well then we're going to wind up with 9 quarters, 9 times whatever the value of a quarter is, plus 4 times the value of a dime, plus 10 times the value of a nickel, and plus 4 times the value of a penny. Oops, that's a P. Okay, so this is one expression that we could make. Now, because this is common sense, a quarter doesn't really value change. A quarter will always be 25 cents. A dime will always be 10 cents. A nickel 5, and a penny 1 cent. So if we go on ahead and substitute those values, we would wind up with 9 times 0.25 for 25 cents, plus 4 times 0.10, plus 10 times 0.05, and plus 4 times 0.01. And this is also an expression that explains how much money he has. We simply substituted the variables for the values we know they are. And it's really that simple. The second question in your packet. Ed wants to find different numbers that will divide evenly into the number 120. He is using prime factorization to help him. Show the prime factorization in exponential form. Alright, so there's a couple different ways to do this, and you all know I prefer the upside down division. 120 is what we're going for, and if you want to use a factor tree, you can do that. Just remember that you have to get all the way down to a prime factor on every branch of the tree. So we will find, let's see, we always start with our lowest. A 1 will get us nowhere, so we want to start with a 2. 2 goes into 120. Well, that leaves us with a 60, which is an even number. So I can put another 2 into 60. That gives me a 30, which is also an even number. Another 2 into it gives me a 15. And I'm out of my even numbers. So now I have to look, and the next highest prime number I can put in there is a 3. A 3 goes into it, and that leaves me out with a 5. And a 3 will no longer go into it, 4 no, and I'm left with a 5. 5 goes into it once, and because I'm at 1, I know I'm done. So that tells me that the factorization of 120 is 2 times 2 times 2 times 3 times 5. So that is the prime factorization of the number 120. But it wants to see it in exponential form. So I need to write down each base. So I'm going to write down my 2's. 2 times 3 times 5. Okay, and now I need to go back and count. I have 1, 2, 3 2's. So that tells me my exponent on the 2 will be a 3. I have 1 3, so my exponent's a 1 or blank, and I have 1 5. So I have the factor of 5 once, and the exponent is a 1 or blank. So the answer in exponential form, the factorization of 120 is 2 to the third times 3 times 5. Now let's think about that. 2 to the third, that's 2 times 2 times 2, 2, 4, 8. Now I'm going to take 8 times 3, that's 24. And 24 times 5, that is 0, 2, 5, 10. That is 120. So we have checked our work. On to number 3. On number 3, we're going to evaluate the expression 10 minus 4 squared minus 7 times 6 divided by 3 plus 10. All right, so I've got to remember to do this problem step by step, and my friend is PEMDAS, because I need the order of operations. There is too much going on here. All right, so my first step is parentheses. Do I have parentheses? I see them right here. Okay, so 10 minus 4, that's going to be addition and subtraction, 6. Go on ahead and carry them down, and now I'm going to rewrite the rest of it. Squared minus 7 times 6 divided by 3 plus 10. All right, so I have no more parentheses. I am good to go. Now I'm going to look, and oh look, I do have an exponent. It's right here. So I'm going to take a look at that. That's 6 squared, or 6 times 6, which is 36. And now I write the rest of the equation down. Minus 7 times 6 divided by 3 plus 10. And now I am done with exponents. Now I need to look at multiplication and division. And remember, I know I'm going to have more of these, so I'm just going to do them from left to right. The 36 is not important to me. Minus, and now I have a 7 times 6, so left to right, 7 times 6. Well, 6 times 6 is 36, plus 6 would be 42. Write the rest of the equation divided by 3 plus 10. And now I'm going to do it again. 36 minus, and now 42 divided by 3. Let's see here. 42, 3 goes into 4 once. 1 times 3 is 3. That leaves a 12, and that'd be 4. 4 times 3 is 12. All right, so 42 divided by 3 is 14. Write the rest of my problem, plus 10. Go on ahead and get this off the screen. We're running out of room. And, oh, look, that's awesome. I'm done with multiplication and division. So now I'm going to look at addition and subtraction. So I have 36 minus 14. 36 minus 14, that's a 2. There's a 2. Okay, so that's 20. Oh, wrong color. 22. Rest of the problem plus 10. And my last addition for this is 22 plus 10. That's easy math. 32. So when we're evaluating the expression like this, we need to make sure that we go step by step through PEMDAS. Once you have everything checked off, you should be down to 0 or nothing left except a number. And that is awesome. Alright. Sam and Mario are apparently in an argument now. Sam said the formula for the surface of a cube is length times width times height. Oh, on your version, this will say volume. I didn't notice it until I took the picture. Sam said the formula for the volume of a cube is length times width times height, or L times W times H. Mary said it's length cubed, or L3. Who is correct? Well, let's take a look at this, and this is going to require a little bit of knowledge of geometry. We have our cube, and I don't want to jinx it. I think this is the best cube I've ever drawn. So you guys get privileged with that. All right, so Sam said that we need to take length. Which one's going to be length? Length, multiply it by width, which gets multiplied by height. And that gives us the volume of our cube. L times W times H, height, equals volume. Now, he is absolutely correct, but in a cube, length is width, which is height. They're all the exact same value. And because they're all the same, I'm going to go on ahead and replace the W and the H. I'm going to substitute them for a length. And because they're all the same, it works. Okay? Length times length times length. That is length times width times height, because length, width, and height are all the same thing. Now, if you remember, we have 3 factors of the L. 3 factors of the L means that we are going to do L cubed equals volume. So, who's correct? It turns out that Mary and Sam are arguing about equivalent expressions. Length times width times height in a cube is the exact same thing as length cubed. Number 5, halfway there. Find an equivalent expression to 4W plus 8W. Now, those of you with the intuitive way of doing this, go for it. But if you're watching this video, I've got a feeling, let's go on ahead and take it out the slow way. Sorry, not the slow way, the long way. So we're going to use the distributive property to figure this out. So the first step we need to do is we need to look at 4W, and that is really just 4 times W plus 8 times W. And now, what is the common factor that those both share? That is our W. I'm going to highlight it in red so that we see it. Both terms, remember a term is a number that we add and subtract, usually has a variable. Both terms have the variable W in them, and the distributive property says that when it's distributed like this, we can pull that out so the W comes here, and that leaves us with a parentheses, 4 plus 8. Alright, so we have W times 4 plus 8, and now remember with our order of operations we have the 4 plus 8, those are like terms, we know we can go on ahead and add them. So we have W times 4 plus 8 is 12, okay, and now with the distributive property, commutative property, we can put those in any order, and we wind up with 12W. And of course, as you know, the intuitive way of doing this, once we understand the distributive property, is we know that as long as these are like terms, we can add or subtract the coefficients depending on our operation. Coefficient of 4 plus the coefficient of 8, that gives us 12W. On to number 6. John needed to show that 3 times 5 equals 5 times 3 using tiles. How could he do that? Well, let's look at it. 3 times 5. What does that mean? And if we remember, talking about the way the British say this, they would say 3 5s. So let's take a look at 3 5s and what they look like. 3 5s, we would have 1, 2, 3, 4, 5. And now we need to make 3 columns of 5. 3, 4, and 5. And now we have 1, 2, 3 5s. Or, oops, let me change up colors. That way we can see the difference. Or we want to look at 5 times 3. 5 times 3 would tell me I need 5 groups of 3. So I would draw 1, 2, 3. Now I need 5 of those. 1, 2, 3, 1, 2, 3, 1, 2, 3, and that's 1, 2, 3, 4, 1, 2, 3, and that's 5. So now I have 1, 2, 3, and I have 5 rows of them. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And then over here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So using these marbles, we have determined that 3 groups of 5 and 5 groups of 3 are, in fact, the same thing and equivalent. Oh boy, this one looks scary. Simplify the equation. Okay, nobody needs to panic. We've got this because we have PEMDAS, right? And we've got all of our different properties. We know what we're doing. So, first thing, let's go on ahead and utilize the distributive property because all of these coefficients out here, they just overcomplicate things. They make things look way too scary. So let's start with that. So we're going to take this 9x and we're going to redistribute it into everything. So we're going to have 9 times x times x plus 9 times x times 3. Okay, now 9xx, that's 9x squared. 9x3, I'm going to go on ahead and multiply my two coefficients. 9 times 3 is 27, and then I have my x. So this 9x is 9x squared, and then that 9x goes to 27x. Now I'm going to hold over my subtraction, and we're going to start working on this next one. It's a lot easier, it makes more sense, and I can actually just describe it a lot quicker. I'm going to go to 2 times x, that gives me 2x, plus, now the 2 times 2, that's 4. My final one, I guess it's kind of difficult. It depends on how you look at it. I like it though. 3 times x squared, so that's 3x squared plus, and now I'm going to take my 3 all the way over here to the 4x. 3 times 4x, that's 12x because I'm just going to multiply the coefficients. And if you're doubting the way the coefficients work, that's why I worked it out longhand there. So now let us go through and we have an x squared and we have an x squared. So those are like terms. We have a 27x, a 2x, and a 12x. So those are like terms. And then we have this lonely constant all by itself. All right, so let's go on ahead and combine them. So our first like terms, we have the x squared minus 3x. So my 9x squared minus 3x squared. If I have 9x squared and I take away 3x squared, I've got 6x squared. And now my next one, I've got 27, what did I just do? 27 minus 2x. Well, that's 25x, but I still have this other 12x plus 12x. So 25x plus 12x. Well, remember, they've got the same term, so I'm just going to add those coefficients. 25 plus 12, that's 37. And y'all can take as many lines as you want on this. I'm just a little confined on space right now, so I'm erasing stuff as I go. And now I need to remember to bring down this lonely coefficient plus 4. So if I take away all of the nastiness involved in this huge dragon of an equation, I wind up with the cute, compact, and fluffy 6x squared plus 37x plus 4. You're going to see a lot of the distributive property, and everybody in math is going to try to scare you away by hiding stuff outside of the parentheses. Don't let them. You guys got this. And in fact, here's another example. So we're going to simplify this equation too. Well, look, they're trying to scare us away with that distributive property again. We're just going to distribute that 2 on inside the equation. So 2 times 6x squared, 2 times 6, that's 12x squared. And then 2 times 4 plus 4 times 2, that's 8. And then we're going to write our other plus here. And look, they didn't even bother with a coefficient. That's awesome. X squared minus 4x plus 7. All right. So I have a 12x squared in x squared, and then I have a 4x, and then I have these 2 lonely coefficients. So let me go on ahead, and I've got my 12x squared. I'm going to add my 1x, and that gives me 13x squared. And now I want to do my x's minus 4x. And now I'm going to add my coefficients. I have an 8 plus 7. That's 8 plus 7 is 15. And I'm done. That's it. That's how easy this is. Now, as long as you keep your symbols together, remember we could rewrite this any way we wanted. So we could say negative 4x. Let me change colors. Negative 4x plus 13x squared plus 15. We could do that. However, mathematical communities will always tell you that your higher exponents stay to the left, and you slowly work your way down to 0 variables. All right, number 9. So I don't know if you figured this out yet or not, but the large part of questions that we're going to deal with from now on involve the distributive property. What are we on? Number 6 or number 4 now working these? All right. So x minus 6, we've got nothing to distribute there, so we'll just go x minus 6 plus, and now we've got 6, so 6 times x is 6x plus, and now I need to put that 6 into the 10 as well. 6 times 10 is 60 minus, and oh look, I got nothing to distribute over here, x minus 10. So now I just got to combine my like terms. I've got an x, got another x, and another x. And then I've got my constants, a 6, a 60, and a 10. Sweet. This is going to be easy. So 1x plus 6x, that's 7x, minus 1x. Well, that was silly. 6x. And now I have a negative 6 plus a 60. So if I start on the negative side of the number line and I'm adding to it, I'm going to move to the right. So negative 6 plus 60, that's a positive 54. And then I'm going to subtract 10 from the positive 54. So that would put me at a positive 44. So my solution for this is 6x plus 44. Number 10, the final equation in our review right now. Find an equivalent expression to 4 parentheses 22 plus 10. We're not going to find one. Let's do a bunch of them. So there is the commutative property, of addition, and that tells me that I can reverse those two numbers. So I have 4 times 10 plus 22. That's an option. I could go on ahead and add them. So I'd have 4 times, what's 10 plus 22? 33. I could go on ahead and do this math. What's 33 times 4? 2, carry the 1, that's another 12, 32. So this is 132. That is an equivalent expression, although it's actually an evaluated expression. We could look at it as distributive. Let's go back up here. If we take this equation and pull it back down, the distributive property tells us that we could take 4 times 22 plus 4 times 10. So that is also an equivalent expression. And of course we could actually put these together. 4 times 22 is 88. And then 4 times 10 is 40. So that is also what did I do wrong? Oh, 4 times 22 is not 88. No, it is 88. Okay. This 10 plus 22. See, this is why we need to check our work. 10 plus 22 is not 33, it's 32. And if it's 32, when I multiply the 4 and the 32 times 4, I get a 8. 4 times 3 is 12, 128 as an evaluation, which now makes sense because this way works out to 128 as well. Hopefully you caught my mistake up here and started going, what are you doing? But if you didn't, that's proof positive. You always got to double check your work. I've been doing this a long time. I'm good at the math, but even I double check my work because mistakes happen. So, hope you've had a good review. Hope this helps you do great on the test. Remember, you bring back your review signed by a parent. That's an extra 10 points on your test. And I'll see you on Monday.